Hello students. So today we are going to discuss in this video reflection at curved surfaces. In last videos and in last class we already discussed about reflection from plane surface or plane mirror or formation of images by plane mirror. Now our next topic is formation of image or reflection from a curved surface. So in this case we have two types of curved surface. One is inward and other is outward portion. So let's start today's topic. If any surface, any mirror is not a plane mirror, it's little bit curved, then such type of mirrors are known as your curved surface. Generally what happen, we use a transparent hollow sphere, cut this hollow sphere from mid part. Likewise, first this is a hollow glass sphere, then we cut this one likewise. Clear? Now as we know that this is the previously this is one is the center of the hollow sphere, this is the inner part, these two are outer part. If we have two curved part, if we polished this hollow glass sphere from inner part, this is your one type of mirror, and if we polished this one from outer side, this is your outer side, likewise this is one is the other sphere. These two are the figure of curved mirror, but they are of different type. In one case polish is inner side, in other case polish is outer side, so they have different name. If polish is on inner side, such type of mirror is known as your convex mirror. Clear? Such type of mirror is known as your convex mirror. And if polished side is outer side, such type of mirror is known as your concave mirror. Clear? I hope these two things are clear. And if any mirror is a part of a sphere, such type of mirrors are known as your spherical mirror. Means these two are the spherical mirrors. Under the spherical mirrors we have two different types of mirror. One is your convex mirror. In convex mirror, polish is inner side of the hollow part, and there is a concave mirror. In case of concave mirror, polish is on outer side of the hollow part of the sphere that previously we have. So these two are the mirrors. Depending upon the polished portion of the spherical mirror, formation of image or characteristics of formation of image is quietly different. They are different one. In this video we must discuss these qualities or these types of images formed by different spherical mirror, concave and convex. As you are observing on your right hand side, there are two spherical mirrors. This one is your convex mirror, this one is your concave mirror, and there is a line just in between passes in between the mirrors. So in this video we are going to discuss some general terms of your spherical mirror. We are going to discuss about general terms. Clear? The very first one term is your pole. What is the pole of the spherical mirror? Pole is the point which is just exactly at the mid of the spherical mirror, only the mirror part. This point P is known as your pole of the mirror. I hope this thing one is clear. Next one is your center of curvature. The center of the hollow sphere from which we obtain the given spherical mirror. It may be this one or this one. Those centers are known as your center of curvature. In this case, center of curvature just behind the mirror, and in this case center of curvature just in front of the mirror. Clear? Sorry, this is not, this one looks like center of curvature. The center of the hollow sphere, always remember that pole is the middle part of the mirror only, and center of curvature is the center of the hollow sphere, not the mirror. Generally some people confuse about pole and center of curvature, so need not to confuse. Center of curvature is the center part of the hollow sphere, and pole is the center or middle part of the mirror only. Now there is another topic, it's the radius of curvature. It is a radius of curvature. So though it's a center, so this distance from center of curvature to pole is known as your radius of curvature. So second point we discussed, center of curvature, already discussed. Then radius of curvature, as you know that radius of curvature is the distance between center of curvature and pole. Center of curvature and pole, this is your radius of curvature. This PC is the radius of curvature. Then next part is principal axis, the straight line. First let me write down principal axis. The straight line which passes through center of curvature and pole of the mirror is known as your principal axis. This line segment, these two line segments are known as your principal axis. Hope this one is clear to you. Now the most important part is your focus part. Principal focus of concave mirror and convex mirror. Only these two are the separate one. So let's start. Let me rub this part. I am going to discuss about principal focus. First part, it's about concave mirror. Okay, it's a principal focus of first one is your concave mirror. Which one is your concave mirror? In this image, this is your concave mirror. Let me rub this one first. Now, what is the definition says in your book? It says that the point on the principal axis where a beam of light traveling parallel to the principal axis after reflection actually meet. Leave as it is. First try to understand. Though this is your mirror, this always produces reflection. Suppose a beam of light or suppose two rays of light coming from an infinity, and those rays of light are parallel to the principal axis. Suppose this ray of light parallel to the principal axis, we always use arrowhead in case of any incident ray of light parallel to the principal axis come and fall on incident on your concave mirror. What happened after reflection? It turns into some direction. Suppose it turns and pass through this portion of the, and likewise it passed through. Then again the second parallel ray of light just incident on curved surface, and after reflection it meets the second ray at some point on principal axis. Means what we observe, we must observe that these two rays, first these two rays are parallel to each other. After reflection they must meet at a point, and that point must lie on the principal axis. If these conditions satisfies, then this point of intersection or point of meeting, actual point of meeting, is known as your focus of your concave mirror or spherical mirror, principal focus, where it's actually meet. That one is known as your principal focus of concave mirror. What about convex mirror? See very carefully. What about convex mirror? So let me rub the board of concave part first. This one. Suppose again the same parallel beam of light coming from infinity parallel to the principal axis fall on the or incident on the curved mirror or spherical mirror or convex mirror. After reflection due to the condition, it move outward, reflect outward likewise. In the same thing happen here. Incident on this, and now what happened? This point and this point, when we produce backward, they are actually, these two rays not actually meet, but when we produce these reflected ray backward, then they appear to meet at some point on principal axis. Likewise, this imaginary part, this imaginary point is known as your principal focus of your convex mirror. Always remember that in case of concave mirror, light ray actually meet, but in this case, in case of convex mirror, light ray does not meet, but when we produce the reflected ray backward, so they meet, they appear to meet, not actually meet, they appear to meet at some point behind the mirror. They appear to meet. That point is known as your principal focus of convex mirror. So I think this one is clear. In this case, reflected ray appear to meet. The word is very clear, appear to meet, and in case of concave mirror, they actually meet. So those points are known as your principal focus of concave mirror and convex mirror. Hope these two all the points are clear to you, and especially these 2 points. Now move to the next part.